Hi students, today we'll talk about the graphical representation of motion. Graphical representation in which we will talk about graphs which give us a lot of information about the motion of an object. So previously, what are the different types of graphs? We have studied so far. We have studied about the displacement, distance, time graph. Now let's look at some other graphs. Let's see what do they interpret. So here we will talk about some velocity time graphs. So I'm having case first. We have a plot like this. So everywhere you can see t is along x-axis as t is independent quantity, and velocity is along y-axis, as we have studied this, that velocity should be on y-axis and time should be on x-axis. What does this graph shows? You can see that this shows that as time increases, velocity also increases. So that means the body has acceleration. So what kind of motion is it? You can see this is uniformly accelerated motion. Why is it so? Because velocity is increasing, but it's increasing equally in equal intervals of time, and that is nothing but a uniform motion. So here this is a uniform motion and the body is also having an acceleration. That means this body will have a constant acceleration. Okay, now let's look at the second scenario. Second graph, consider second graph, that is, we again have here a graph plot like this, and this shows that the velocity is constant with time. So what does this show? This shows that even though your time keeps on increasing, but your velocity is constant. Say at 1 hour your velocity is 3, at 2 hour velocity is again 3, at 3 hour velocity is again 3 km per hour. It means at every time is increasing, but with the increase in time, your velocity is constant at a value of 3 km per hour. So velocity is constant, and this implies that acceleration is zero here, because your velocity is not changing with time. So that means this body does not have any acceleration. So the body moves with uniform velocity, and this represents a uniform motion because it's moving with a uniform velocity. So this represents a uniform motion, that is, body moves with uniform velocity. Now let's look at the case 3. In this plot we have a straight line which is declining, and that means as your time is increasing, the value of velocity decreases. So here, whenever velocity increases with time, we call it acceleration, right? So whenever velocity decreases with time, we generally use another term, that is retardation, or you can say negative acceleration, or it's also sometimes called deceleration. So in this case we say that the object, that the body, it's uniformly retarded motion here. And why it is uniform? Because the decrease is uniform. You can see here, for every 1 hour the decrease is 1 kilometer per hour. First, see here, first decreases from velocity decrease from 3 to 2, then velocity decrease from 2 to 1. It means it's decreasing uniformly. So this decrease in velocity with time is known as retardation or negative acceleration. Okay, so these are some of the scenarios, some of the facts which are depicted by velocity time graph. It was just to tell you how the graphical representation of motion is also helpful. Just by looking at the graphs, you can tell about the motion of that object. Now look up another interesting thing here, that from velocity time curve we also get displacement. From velocity time curve we also get displacement. Okay, in one of the previous slide I told you that slope of velocity time graph gives acceleration, right? So now we will see how we can determine acceleration from velocity time curve. Okay, now let's take the simple case where the object is moving with uniform velocity. Okay, so how could be the graph? So this is our graph. Say if the object is moving with uniform velocity, say velocity of 3, that means velocity is constant with time. This is how your graph looks like, right? Now area under this velocity time curve would mean this area which is shaded by the red lines, right? What would be this area? This area will be this area of the figure, and you can see this figure is of shape of a rectangle. So this area will be the area of rectangle, right? And what is the area of rectangle? That is length into breadth. So here you can see in this figure, our rectangle, in this rectangle, length is OA and breadth is OB. So here area is equivalent to OA into OB. What's OA? OA is nothing but time. And what is OB? It represents velocity. So instead of OA, it's time, and instead of OB, it's velocity. So area is nothing but velocity into time. Now, by definition of velocity, we know velocity is change of displacement over time. So it means velocity into time can be written as displacement, because from the definition of velocity, velocity is equal to displacement by time, and you will, when time will be multiplied by velocity, you will get displacement. It means from this area we will get displacement. So therefore this area under the curve is equal to displacement. And so from velocity time curve you can identify two things: slope of velocity time graph will give us acceleration, and area under the velocity time curve will give you displacement. So what are the conclusions we get from distance time graphs and the velocity time graphs, or you can say position time graphs and velocity time graphs? So here slope of position time graph or distance time graph gives us velocity, and the velocity, you know that velocity is change of position with time, that's distance by time, sorry, displacement by time. Slope of velocity time graph gives acceleration, and acceleration is nothing but a change of velocity with time, that's velocity by time. And area under the velocity time graph for uniformly accelerated motion gives us displacement. And this was all about the graphical representations of motions. Thank you.